How big is the universe? It sounds like a simple question, the kind a curious child might ask. But to answer it, we must journey across scales so vast, so unimaginable, that even the numbers strain to contain the truth. We begin at home. Earth, a spinning sphere of life floating in a black ocean. It orbits a star we call the sun. Our sun, just one ordinary star, is nothing but small. You could fit about 1.3 million Earths inside it. If the sun were a hollow sphere, Earth would be a tiny marble rattling around in it. The sun makes up 99.8% of the mass of our entire solar system. Everything else, planets, moons, asteroids, are just cosmic crumbs compared to its weight. And yet, it's still a medium-sized star. Out there, in the deeper reaches of space, there are stars hundreds, even thousands of times larger than our sun. And our sun? Just one pixel in the Milky Way. One of over 100 billion stars in a galaxy called the Milky Way. Now imagine this. If the sun were the size of a grain of sand, the Milky Way would stretch over 100 kilometers wide. That's just one galaxy. The Milky Way is part of a small neighborhood of galaxies, the Local Group. We share this region with the Andromeda Galaxy and dozens of dwarf galaxies. But zoom out again, and the Local Group becomes a tiny part of a larger structure, the Virgo Supercluster, a collection of thousands of galaxies. And beyond that, the Laniakea Supercluster, stretching over 500 million light-years across. These superclusters form the cosmic web, an intricate structure of filaments and voids like neurons in a brain the size of the universe. From what we can measure, the observable universe stretches 93 billion light-years across. That means if light had been traveling in all directions since the Big Bang, 13.8 billion years ago, the farthest edge we can detect has been pushed outward by space expanding. We're not at the center, but everywhere in the universe sees itself as the center because space expands uniformly in all directions. So, the edge is not a wall. It's a limit of vision, a cosmic horizon. But even this is not the full picture. What we can see is only a sliver of what's out there. Scientists estimate that just 5% of the universe is made of ordinary matter, stars, planets, dust, gas, everything we know. The other 95%? A mystery. Dark matter, invisible, but with mass. It bends light and shapes galaxies. And dark energy, a repulsive force, accelerating the expansion of the universe. We don't know what they are, but without them, galaxies wouldn't exist. Neither would we. So, how big is it really? We don't know. It could be infinite, stretching forever in all directions, beyond the reach of time and light. Or maybe it loops back on itself, like the surface of a sphere in 4 dimensions. And then there's the theory that our universe is just one bubble in a vast foam of universes, the multiverse, each with different physics, different laws, maybe even different versions of you. You are smaller than a speck in a galaxy among trillions. And yet, you are the only part of the universe we know that can ask these questions. You can map the stars, discover atoms, look 13 billion years into the past, and wonder what came before. The universe may be massive, but the fact that it gave rise to a mind that can contemplate itself might be the most astonishing thing of all. This is only the beginning. Space, time, gravity, consciousness, life. We'll explore them all. Because to ask, to seek, to wonder, that's what it means to be part of everything.